Hello friends, welcome to the session on tension members. So today we'll take up one example on diamond type of bolting. Determine tensile strength of the plate 160 by 8. So 160 is the width, 8 is the thickness of this plate. Connected to 10 mm thick gusset plate using 16 mm bolts. Fy is 250, Fe is 410 is used. Now this is the diagram given. So these dimensions they will be given from here, bolt center, so this is 30, 40, 40, 30. So similarly these dimensions. So all these things they will be given 30, 25, 25, 25, 25, 30. Now here width of the plate is given. So this width is 160. Now it is said that plate is 8 mm. So this plate 8 mm tension plate, and this is gusset plate, and gusset plate thickness is given 10 mm gusset plate. Here edge distance E is 30 mm, pitch distance P is 40, and the gauge distance G is this 25. Write down all these values. So we'll start with analysis. So first, TDG, yield stress, yield strength. TDG is AG Fy by gamma m naught. So AG is B into T, thickness. So B is 160, thickness is 8 into Fy 250 divided by 1.1. So you have the value 290.9 kilonewtons. Now second, rupture strength. So rupture strength is given by, so TDN is equal to 0.9 AN Fu by gamma ml. Now here AN is net area at critical section. So here we need to determine net area. Now here we have to analyze this joint for all possible failures. So let me say this starting point is 1, this bolt is 2, similar again this is 2, and this starting point is 1. So first chance is this bolt may fail like this. So failure along 1, 2, 2, 1. Second is from here it may come like this, here, and again like this. So I will say 1, 3, 3, 2, 1. Third possibility is the failure may come here like this. 1, 2, 3, 4, 3, 2, 1. So I have to find all possible chances of failures and find out its net area, and whatever is the least or minimum area that we have to consider. So first let me write the equation for generalized equation for diamond type of bolting. So AN is equal to, just look here, this is a diamond type of bolting. It is given in page 33. This is the gauge distance, this is the pitch or staggered pitch, what we call, overall width B, and its equation is given by AN is equal to B minus N into DH or D naught plus summation of P square by 4G. So summation means number of slant lines. G is gauge, DH or D naught is bolt hole, N is number of bolts in the considered line, T is the thickness, and B is the width. So this is equal to B minus N D naught plus summation of PSI square by 4G into T. This is the generalized equation. Now I will write for each of the sections separately. First let me write for AN 1, 2, 2, 1 along this section. So this is B is 160 minus here N, number of bolt holes in this given direction. So along this line number of bolt holes are 1, 2 and 3. So number of bolt holes 1, 2, 3 minus 3 into D naught. D naught is 18 plus here PS square. Summation of PS square means number of slant lines. If I have to consider this, so here number of slant lines are 0. So this becomes 0 into T. So T is 8. So solving this I have the answer 848 mm square. If you consider section 1, 2, 1, this is a straight line, not zigzag. So this equation is for zigzag lines only. Next, A N for 1, 2, 3, 2, 1. A section like this 1, 2, 3, 3, 2, 1 like this. So here B 160 minus N, number of bolt holes 1, 2, 3, 4. 4 into D naught. So D naught is 80 plus summation. Instead of summation I will write first number of slant lines. If you look at this equation, how many number of slant lines along this line? 1 and 2. 2 slant lines plus 2 into G square. G is gauge distance, 40 square divided by 4 into P square. 2 into P square divided by 4 into G. G is gauge into 8. So here I will write this is gauge distance, this is pitch, this is number of slant lines into G. So I have the answer 960 mm square. Similarly I will write along A 1, 2, 3, 4, 3, 2, 1. This line 1, 2, 3, 4, 3, 2, 1. Now if you look here, number of bolt holes are 1, 2, 3, 4, 5. So N is 5. Slant distance 1, 2, 3, 4. 4 are slant. So substitute the values here is equal to B minus 160 minus number of bolt holes 5 into D naught 18 plus number of slant lines 4 into pitch square 40 square divided by 4 into gauge distance 25 into thickness 8. So solving this you have the answer 1072 mm square. Among these 1, 2, 3 values, choose the least value. So least value is N. Therefore net area at critical section. Critical section means the section where it may fail likely. Critical section is 1, 2, 1 is equal to 848 mm square. So substitute the values in TDN. So TDN is equal to 0.9 into AN net area. So net area is 848 into FY 410 divided by 1.25. So you have the value 250.9 kilonewtons. Now for diamond type of bolting, there is no necessary to calculate block shear. Only this much is sufficient. So compare this value and this value. Whichever is the least, that is the tensile strength of the joint. So here tensile strength of the joint is 250.9. Tensile strength is 250.9 kilonewtons. So this completes the problem. Thank you.